Well, it's certainly an honor, first of all, to have been invited to present at your conference. It's a pity I couldn't make it. Very unfortunate given the circumstances, but understandable, I suppose. In any case, I miss you. I would have loved to have met all of you, fellow map nerds, and I was very excited about it. But I do hope that someday we can reschedule this, and I will get the chance to meet you lovely folks. So you should be seeing a sketch of Europe on the screen on some drawing paper. And here is Europe in the context of lines of latitude and longitude, the graticule here. And you may or may not be surprised, and I'm curious what you think of this. In the United States, people generally think of Europe as being at about the same latitude. It's just straight east across the ocean, that's Europe. United States and Europe, we're kind of even, and we think that because we have a similar climate. So if I start filling in this drawing a little bit with some other countries for context, some watercolor, and then just go full on and make it a globe, and rotate that globe a little bit, we can see that the United States and Europe are actually not very even with each other in the latitudinal sense. Europe is actually much more closely aligned with Canada, which is a surprise to a lot of Americans, certainly American kids, all the way up through American adults. And I'm actually kind of curious if Europeans have the same construct in their mind that they're even with the United States because of our shared climate or similar climate. But in reality, Venice is at the same latitude as Minneapolis, Minnesota. Now, I don't know if you're familiar with Minneapolis, Minnesota, but it certainly does not give the same vibe as Venice, even though we're at the same latitude. And this map isn't actually paper, right? It's not paper gores glued onto anything. It was just all faked up in ArcGIS Pro using samples of paper and little goofy tricks that I use to make it look like it's drawn and watercolored and stretched onto a globe. And actually my first professional experience as a geographer and GIS technician of sorts was with paper maps. So I worked for the water distribution department for the local municipality where I grew up, Mount Pleasant, Michigan, a small town in Michigan with wells and a water system. And it was my job to put on a GPS backpack and walk around with a metal detector and swipe it around and find the water service pipes that connected everybody's home to the main. And so we would have a digital version of this. And it was actually quite offensive that we were trying to replace the existing paper system, which was little index cards of every address in Mount Pleasant. And you would look it up, you would pull out an address, and it would say the water service is located 15 paces in from the street and 6 paces east of the walnut tree on the northwest corner of something ridiculous like this, right? But the folks who worked there at the time thought this was a great system, and they thought so because they had essentially had all of it memorized, right? This was their system of record. This was their geographic information system, all on sheets of paper. Now, relatedly, here's a quiz that my niece Cadence took several years ago where she defined the map as the world on a sheet of paper, but her spelling was, of course, a little bit more insightful than she probably thought it would be. And this is just a piece of solid gold. But oftentimes, Cadence's description of what a map is absolutely spot on correct. Cadence is very frequently right about this sort of thing. And I didn't do a good job at the time of defending what I was doing and why we were making a digital version of that filing cabinet. But the person who managed the water department was named Malcolm Fox, and he did a great job of kind of getting between those people and me and defending it. And he showed me a lot of grace, and he stuck up for me. And I'm very grateful for that. And I recognize that my whole life is just a line of people who have supported me and invested in me and stuck up for me and showed me grace when I wasn't really able to explain what I was doing and why I was doing it. And I'm very thankful for Malcolm and all the people after and before Malcolm. And so, as a way to kick this off, I'd like everyone here to think of someone in your professional career when you were new, when you were just starting out, when you were learning, when you were a novice, and didn't know exactly which way to go or how to do something, and somebody invested in you. They gave you their time, they gave you some wisdom, and they showed you grace when you may or may not have deserved it, right? So think of a name of somebody who's done that for you, and I'll give you a couple seconds to think of that. Well, I'm hopeful that you were able to think of someone, and if you had a problem thinking of it, maybe it was because you had too many names, right? Too many names. And so the accidental lesson there is that we're cared for, and we're all just people, we're all doing our job, and we're investing in each other. And it's really a lovely community that we have. You know, you're over in Germany and in Switzerland, and I'm here in the United States, but I feel a sense of friendship and kinship with you because we're all in this together. So let me dive into a little demo here. So this is a NASA website for active fire data, and there are actually 2 satellites whizzing around the Earth at this very moment. I'll pull this up. And they're detecting thermal anomalies, among other things. So I'll look up NASA active fires and active fire data. And it's really remarkable. What a time to be alive, right? So there are different formats you can download. There's a text option, just a simple TXT file. And I'll choose the MODIS satellite for the whole world coverage over the last rolling 7 days. I'll click this, and it's downloaded. I'll open this in Microsoft Excel, and it's just a simple table. Latitude, longitude, how bright was that 1 kilometer piece of the Earth, the scan and the track position, date, time information, which is interesting. Which satellite, was it satellite A or satellite T? How confident are we that this was an actual fire and not a reflection off of a shiny metal roof or a Boy Scouts fire in the woods? The fire radiative power, how much energy is being released in that 1 square kilometer because of this thermal anomaly, they call it. Was it daytime or nighttime? Amazing data, amazing data. And it's all automated and sent right down the pipe into my Excel document here. And so I was looking at this and I thought, okay, we can play around with this. I don't know if you're familiar with pivot tables, but pivot tables are a lot of fun, and it's a very easy, interesting way to slice up data. So you're not stuck with columns and rows as they are. You can slice it and dice it. So I'm just going to give you a quick primer on pivot tables. And I'll insert pivot table. And I'll say, well, gosh, let's see. I'll choose satellite. Was it satellite A or satellite T? Was it day or was it nighttime in the columns? And you can see that I'm just slicing and dicing. So fire radiative power can go into the values area here. And so now we're just seeing the cumulative energy released at each of those 1 kilometer cells. Was it daytime or nighttime? Was it satellite A or was it satellite T? And these are just numbers, and numbers are actually abstractions. They're rather abstract things. And I look at this and I don't intrinsically have a sense of magnitude or scale. But something that we geographers like to do is color code stuff. Good grief. When we were kids, it was all about crayons. We were coloring everything in. That's what we do. So I'll come here and I'll do some conditional formatting on these, and I'll say, here. Now, immediately, boom, we get a visual sense, a visceral sense for the amount of energy released by these fires, right? More and less. Okay, well, taking a step back at this data, here's latitude and longitude. We're geographers, so naturally we focus on that sort of thing. And I'm just going to get a rounded version of these. I want to round them to the nearest ordinate. So instead of all these levels of precision, these decimal places, I'll just round it. So I'll say equals round, choose latitude, and I'll say 0 decimals of precision equals round, I'll say longitude 0 decimals of precision. And then I'll flood fill that right on down to all of my data. I'll call this lat for short. I'll call this long for short, which sounds kind of ironic. Long for short. And then I'll select everything and say, well, there's this thing called confidence. And I'll go into the data tab and I'll filter out everything that the satellite isn't just absolutely sure isn't a fire. So now I'm only seeing things that the satellite has determined to be absolutely a fire. 100% confident that this is a fire. Okay, now let's grab this and insert a pivot table. And we'll look here and think, you know what? Latitude. What is latitude? I was looking at this and I thought, what is latitude? Latitude is nothing more than up-downiness. And that's what rows are in a table. So I'm going to choose latitude and assign that to the rows. And longitude, or as my English friends would say, longitude, is nothing more than east-westiness or left-rightiness. So I'll choose longitude and I'll drag it into the columns. Oops. Latitude, my shortened versions, and longitude into the columns. Now the way latitude works is we start at 0 at the equator and we count up to 90 at the North Pole. And so I'm going to reverse this sort. And then I'm going to choose fire radiative power, how much energy is released. And I'll just give these guys a squarish orientation. And I'll zoom out. And I should be seeing something that is familiar to you all, something familiar to any geographer. And that is an accidental portrait of Earth right now. And like I was saying before, we geographers like to color in. And so I'll grab all of these cells and say, you'll have a black background, and give it kind of a gray text. I'll make the font quite small. And now I'll go into the conditional formatting. This time I'll give it 3 color scales. The lowest 10 percentile, I'll give a kind of a deep purple. Midpoint can be red hot fire. And the top 10 percentile can be just blazing white hot yellow. And now I have in Excel a pseudo map of the world showing the cumulative energy released from fires in the last week. Now I'm calling this a map, but Excel has no idea that it's a map. This is a pivot table, right? This is a conditionally formatted pivot table. It's not a map. It only becomes a map when our human eyeballs look at this and our cognitive systems process this and recognize shapes and patterns to be a spatial phenomenon. And we call that a map. Excel has no idea that it's a map. I'm going to close this, and I'm not even going to save it because it was too easy, and I can always redo it later. So here's another way of pivoting data. This data has no geographic component whatsoever, and I pivoted this. This is the, it's actually quite sad. So this is traffic fatality data that involved a pedestrian in the United States. And I did a pivot table based on the time of year as rows and the time of day as columns across the top. So midnight through noon to the middle, all the way to midnight again on the right, and then fall to summer to spring to winter going up. and we see something that has a distinct pattern, a shelf of an elevated risk to pedestrians, which are people walking on the street or on the sidewalk near the street, and they were involved in a traffic fatality. And we see a distinct shift. And it doesn't take a whole lot of reasoning to realize that, okay, dawn and dusk are very dangerous times for people to walk. Dusk is a dangerous time to be a pedestrian because people are driving and it's difficult to see people on the road because the sun is in their eyes and they're more likely to get into an accident and hit a pedestrian. Now, the interesting thing here is, why is it curved? I mean, you're muted, so normally at this point I would shout out, why is it curved? And everybody kind of throw out their ideas, and you're geographers. And so you probably know why it's curved, and that's because the seasonal shift of dusk changes its time throughout the year because of our axial tilt as we go around our home star. Earth is 23.5 degrees tilted, and dusk changes relative to the time of day throughout the year. And so what we're seeing here is this echo of a phenomenon of a round Earth orbiting around a star. And we're seeing this in non-geographic data, human data, echoing the form and the structure of our planet itself. Geography is different. Geography is going to find a way. Geography isn't just another data format. It's not just another medium of quantitative information. Geography and spatial data as a whole open up an entirely new dimension and show us a new, more intrinsic way of thinking about our world and our lives. And the second accidental lesson here is, you're the one who makes the maps. And what's more is, you're the one who makes it a map when you behold it. It becomes a map in your mind. We work with very powerful, very technical software. Now, you just saw me make a map in Microsoft Excel, and we dive in and out of algorithms and tools and systems designed to make maps. But make no mistake, those systems don't know they're making a map. They don't know anything other than the commands that we programmed into them. It's up to us to use those tools to explore geographic data and come up with our own conclusions as a result. Here is a map, also made in Microsoft Excel, of tornadoes in the United States since 1950, aggregated. You can see a distinct trend here. Now, I am from Michigan in the United States, which is near the Midwest. And when I was a little boy, there were two things that I was deadly afraid of. The first was Tim Curry's portrayal of Pennywise the Clown in the Stephen King miniseries It. It almost ruined my childhood. The second thing was tornadoes. Terrified of tornadoes. Every kid in the Midwest and many adults in the Midwest are terrified of tornadoes. Now, here is a map showing all of the tornadoes. This time it's not in Microsoft Excel. It's actually in a software program designed to make maps, if you can believe it. So here are all those tornadoes since 1950. Now, here they are color-coded by what season of the year they occurred. And we can kind of fuzz our eyes and get a very basic sense. Okay, you know, there's a cluster of colors here, and it kind of migrates to the north and gets a little bit warmer in color. But we need a little bit more help to actually understand this. So here it is, filtered out by early in the year and the geographic mean of those tornadoes locations early in the year. And we can just sequence through the months of the year and see a movement as a phenomenon grows up north and then kind of dissipates and falls back to the sea throughout the year. And if we show all of those at the same time, we get a pattern. So the geographic location on average of these tornadoes changes throughout the year, and we get this very interesting symbol, which looks like the infinity symbol, crosses itself, and when I saw it, it reminded me of something. It reminded me of this globe that hangs in my office that my wife Danielle got for me. It's an old globe. She found it at a vintage store, and this is an analemma. And I've always had a hard time kind of understanding, honestly, what an analemma is and what it's showing. It's very bizarre and complex to me. So back to this map data, when I was making this and I was isolating those months, I thought, gosh, it would be also very nice to show just a simple aggregation per month and color code it by the month. And so I made very small, small multiple series of maps for the location and intensity of tornadoes, color coded by month. And in this way, I didn't have to make a legend that looks like a silly math equation. I can just show the data in two different dimensions, and because they share a common color scheme, they decode each other. And the accidental legend lesson here is that I don't love legends. Legends are kind of an unfortunate reality, but if you can avoid them by making them something else, then there's an added level of visual dimension to explore. So here's that map, and it's actually quite easy to play with layouts in ArcGIS Pro. So here it is with those monthly breakouts shown underneath it in a poster style format. And it actually reminded me of a work that I had done in the past of bird migration. It was very similar, and the pattern seasonally was really similar. There was a lot of overlap between these two things, tornadoes and birds, right? That's bizarre. And I made that map of small multiples, but I also thought, well, I've got all these little maps, why don't I just stack them up into an animation? Because why not, right? But the data also reminded me of a map that I made more recently of the sea ice extent throughout the last 40 years. And when I look at this and I color code it by year, actually color code it by month, over all those years, I get a very distinct sense of change and a cyclical pattern. So here is 40 years of data all squished together into one map and then filtered out by the month of the year. And we get this kind of breathing heartbeat pulse of a planet as energy migrates from the north to the south, to the north and the south, and you get this beautiful repeating cycle of the energy budget transferring itself up and down, in and out, which is really no different than this, right? So this is 12 cloud-free NASA image mosaics all stitched together into a simple sequence. And when we put things into motion, they reveal something, and they have an emotional impact that they might not have had otherwise. And what are we even seeing? What's the root of all this? Well, really what we're just seeing, like I said, is the Earth revolving around our sun because of its 23.5-degree axial tilt. We have a migration of the direct rays of the sun. And all of these maps mimic that underlying phenomenon. They give us a clue about something deeper. And here is the source of an analemma. So this is a camera positioned at the same location on the Earth, and a snapshot taken at regular intervals throughout the year at the same time of day to show the tracking location of the sun. And that's an analemma. So the accidental lesson here is that maps reveal a deeper phenomenon. Yes, they're showing you one thing, but oftentimes they show you a shared perspective of something much deeper. When I was making those small inset maps, they were actually quite fascinating. And so I thought, well, maybe there's another way I can look at this. And so here are those tornado locations broken out by month. But then I just showed all the month aggregations stacked up on top of each other, month after month after month after month. And the result was something that was actually rather beautiful, sort of charming. Each location gave you a mandala-like icon representation of its local seasonality. And then if you step back and sort of blur your eyes a little bit, you get a sense for a national trend as well, given those seasonal colorations and scaling based on overall intensity. And the accidental lesson here is what is going on in West Virginia. Tornadoes hate mountains. That's a quick accidental lesson we can take away here. So if I go back to that data and I only isolate the wintertime months, it looks like this. If I isolate the springtime months, it looks like this. Summertime, autumn, And if I just cycle all those months, we get, again, this sort of breathing, pulsing, cyclical sensation where you've got a phenomena building in intensity in the south, growing with rage up into the north, and then dissipating seasonally in the north and falling like a wave back to the sea in the southeast. And I'm showing you this because this is just one data set with a bunch of different ways of visualizing it and understanding it. And there's no single best way to tell a story. There's no one best map. There's all sorts of lessons to be revealed in any way that you choose to display your map. And also one idea leads to the next. One map got me curious about another map, which got me curious about another map, which is a lot of fun. So speaking of one map leading to another map, NASA every few years releases an Earth at night image data set of nighttime lights. And it's really this marvelous picture of humanity's location on the surface of the Earth, right? It's a bit of a proxy for population. And it's this wonderful, wonderful thing. And it says, we are here. This is a self-portrait of mankind. And in 2016, they released an update. So the last version had been released in 2012. 2017, they released it for 2016 data. So you've got these two versions of the same phenomenon 4 years apart. Now that's very interesting, and that opens up all sorts of possibilities. Now I found myself looking at 2016 and marveling at just the span and the stretch of humanity's reach on the surface of our Earth, and you can recognize cities and the tendrils that grow out from all of these areas. And this is us. This is where we live, right? And if I look at 2012 and then back at 2016, back at 2012, I'm trying to find a pattern, right? Has it changed? How has it changed? And I thought, gosh, I'm using GIS. Why don't I just do a simple change detection? So I did a quick minus, which took about 1/10 of a second, and I was looking immediately at a change detection in the nighttime lights of humanity over a 4-year period. Black has reduced and white has increased. Now I recolored this so that blue showed a decrease in nighttime lights, yellow showed an increase, and I just made all of the pixels between those two transparent. And because I wanted some context, I pulled in some imagery as a background and then really dimmed it because I didn't want it to fight with the phenomenon that I was mapping itself. And then I took a look, right? You see these locations of oil fields playing out and growing and being abandoned and being moved into. You've got the massive electrification projects of Northeast India that occurred over those 4 years. I had no idea about this. I saw this incredible illumination of Northeast India based on this change detection, and it led me to Google that, and I learned about a big project where electricity was brought to those rural areas of Northeast India for the first time. And likewise, just like some places have the optimism of new electricity and new development, you have places of conflict and strife and places where the lights have gone fully out in the last 4 years. So here's a picture of Syria over these intervening 4 years where their nation is plunged into almost absolute darkness at night, except for a couple staging areas for operations in the middle of the country. And the accidental lesson here is that maps answer questions that I wouldn't have thought to ask. Does anyone recognize this man? Anyone recognize this person? Shout it. Shout it out loud. Okay. This is Edward Imhoff, right? This is Edward Imhoff, one of the greatest cartographers of the 20th century, an amazing legacy that he's left, a tremendous artist, and he is perhaps the best known relief mapping cartographer. So his depiction of mountains, particularly Swiss mountains, Edward Imhoff is a Swiss gentleman, was a Swiss gentleman, are incredibly famous. But before he was a famous cartographer mapping the mountains of Switzerland and ultimately the world, he was little Eddie Imhoff. So here's Ed as a young boy. But look at this, age 11. He's still doing incredible cartography that's probably better than anything I've ever done, and he's 11 years old. But he also happened to be a painter. He's an artist. And there's a lot of overlap in these skills. And I looked at this and I thought, goodness, Edward Imhoff painted this at the age of 14, 1909. So you can see some influences of the Impressionist era. I'm looking at this and I think, wow, what an amazing overlap of talents. But really, this is the painting of a geodesist and a cartographer, right? Who else could do something like this and focus so strongly on the pattern and the perfect 3D perspective of the tile floor? And what's more is, what's the subject of this? I looked at this, and Edward Imhoff is famous for his impressionistic depictions of light and shadow on the surface of the earth. And I'm looking at this, and I don't see any shadows. What happened, right? What's going on? And then it hit me. What's the focus? The focus of this painting is not Edward's sister in the distance. The focus of this painting is the center of this piano. Now look at this. It's almost a photorealistic depiction of light and reflection and hues on the surface of this wooden piano. Isn't that amazing? Right? 14 years old. And Edward Imhoff was a painter throughout his life. Here's a watercolor that he did near the end of his life. And he had a remarkable sense for atmospheric perspective. Atmospheric perspective means you lighten and desaturate content in the distance to replicate the effect of the scattering of light through our thin, precarious atmosphere that we're all living within. So at distance, things become more misty and gray. Now, if I sample the colors of land as you move further into the distance in this Imhoff watercolor, you get some very different hues, right? Different hues, different tones, different lightness. And here they are in a gradient, which when we bring back the context of the image, you can see a distinct line of brighter and vibrant, more saturated colors blending out into a more muted, lighter color palette in the distance. And he did some remarkable work, and of course he employed that same technique in all of his paintings. So he's using a warmer color palette here, but he's also using the atmospheric perspective of lightened, desaturated colors in the distance. And his sense for creating a sense of warmth or coolness using the color palette is very obvious. Here's a beautiful, warm, amber orange toned image of autumn in his hometown. Now contrast that with this, right? Amazing difference just in the use of tone. Look at the difference between these two things and his command of color. But he was also a remarkable hand-painted topographic mapper. So he drew this as one of the topographic inputs for an atlas of Switzerland. This is the Zurich canton, I believe. And look at his remarkable fluidity of different landform types. You've got these very abrupt, jagged, rugged peaks in the east and a couple in the west here, and balanced by this kind of slowly undulating erosional landforms with lower relief here, and then these kind of interesting glacial deposit rivulet features here with strongly linear characteristics. It's very difficult, of course, to do this in the digital environment, but he was using a hillshade algorithm inside his brain. And so he could just do this because he was holding the graphite in his hand, and he knew how to best represent different landforms individually. Now, here is a digital version of a direct single direction, single light source hillshade of that same area. Now you do get an okay representation of the stark, severe mountains in the east and that ridge line in the west, but it's not the same. Now here's also digital multi-directional version of hillshade with a lot of different virtual sun angles. And we do gain back a little bit of the gentle undulation features in the center of the area, but we might lose a little bit of the overall structure of those jagged mountain peaks. And so different techniques work well for different areas, but overall, Edward Imhoff was able to employ all of those techniques into a single representation of hillshade. Now here is one of his most famous works, which is the topography of the, and I'm going to say it wrong, the Walensee, I don't know how to pronounce it, but I know how it's spelled. The Walensee Lake region and the mountains surrounding it. And that's just this beautiful, beautiful depiction. It's actually quite large. And I looked at it and I thought, here are the isolated colors that he used for the sunlit slopes. So we're only looking at the areas of direct sunlight on Edward's hand-painted topography. Now here we've isolated only the shadow areas. And look at the difference between those two, right? And it should give us this sense that, yes, this is a person in command of using hue and color and tone to denote the feeling of a place. Warm sunlit slopes, cool shaded mountain slopes. And let's think about atmospheric perspective now and color. So if I'm looking at the hues here, and if I blur it for you, if you blur your eyes, I've blurred it for you, you can see a distinct difference in color based on elevation. This is interesting. So here I've isolated only the low or the high areas, the peaks, and here I've isolated only the low-lying areas. So the only difference here is elevation. High elevation and low elevation. Two very distinct palettes that he's using, right? Because he's familiar with the artist's concept of atmospheric perspective and looking through a thick atmosphere into objects that are more distant than others. So let's try to perhaps recreate a little bit of this sense in the digital environment. So here is some satellite imagery of the beautiful nation of Switzerland. And on top of this, I've dropped a traditional hillshade with a single light source, which is actually quite lovely. But if I apply the color scheme that I sampled from Edward Imhoff's paintings and give the sunlit slopes these nice warm amber and yellow tones, I give no color to the intermediate tones, and then I give a deep blue and then crimson color to the shaded areas, we get something that looks like this. Now we're a long ways off from anything that looks remarkably or remotely Imhoff-like, but let's keep going. So here's the imagery once more, and here is a hillshade rendering, digital hillshade rendering with using a multi-directional technique. And if we apply that same color scheme in the multi-directional sense, with no ink in the reasonably flat midtones, it looks like this. So we're seeing through to the imagery below where there's very little relief. And here they are combined on top of each other. So we're showing both of them. The single direction hillshade does a good job of showing the stark mountainous overall form of Switzerland, and the multi-directional hillshade does a good job of showing the more undulating smooth areas in the north and the west. So here we are back with our imagery once more, and let's pull in just the raw digital elevation model, and we'll give it a color scheme sampled from Edward Imhoff's palette of lower elevation areas, and we'll fade that up to absolutely nothing in higher elevation areas. And the result is this. So this layer of kind of a blue-green mist that hugs low-lying areas, and no mist at the higher elevations. And when we combine all of those together, the imagery with the single directional hillshade, the multi-directional hillshade, and that simple mist overlay, we get something that actually is rather Imhoff-like, something that at least echoes the tone and the quality of Imhoff's work. And here's the border of Switzerland, just to give a little bit more context. And this technique can be used all over the world, not just Switzerland, of course. And here it is applied to the Grand Canyon in my home country. Here it is applied to the Columbia River Gorge in the northwest section of the United States. My sister lives perched along one of those little ridges. It's just a lovely area and looks good in the Imhoff technique. And it can be used to compare and contrast the relative topography of different national parks, let's say, throughout the United States. And the cool thing is it's not hand-painted, which means it scales. So if I'm looking at a map at this scale, the system applies all the way down as long as we have data to support it. So here is a map of Switzerland, which was printed out as one of the poster offerings at the conference this past week. Hopefully some of you got one of those. If you didn't get one, bug Mark. Mark said he would hand print any number of posters for everyone who wants one at his own expense. Here's a couple close-ups of Switzerland using that poster. Now, I've made this resource available as a source ArcGIS Pro project. I've made it available as a style for ArcGIS Pro with instructions on how to apply that to your own data set. So if you're interested in doing this for yourself, give this a shot. That's esriurl.com/imhoff. So here is an image of hand-drawn hillshade of the Yellowstone National Park area in the United States by a topographic artist named Herwig Schutzler. And Herwig Schutzler also painted this hillshade for and he worked for Rand McNally. And Rand McNally eventually spun off his section, and he was working for what became MapQuest, which is pretty interesting, right? So I saw this hand-shaded hillshade by Herwig Schutzler. Gosh, it was done decades and decades ago. 1965, if I squint. This was painted by an artist in 1965, and it's just wonderful, right? It's actually hard to get a hillshade at this scale that's not too detailed. And so if I apply a color scheme that paints out the middle tones and gives Imhoff-like qualities to the sunlit slopes, and then cool red colors to the shaded areas, and then put some imagery behind it for context and texture, we get something that looks like this. This really kind of charming hand-drawn quality map of the world that blends data from today with the artistry of yesterday. And I think that there's something beautiful about combining the work of someone from decades ago with very new, updated methods of today. And I smushed these two things together, and I wrote about that in a blog post because I can't shut up about stuff like this. And I actually got an email, and it turns out the email was from Herwig Schutzler. He's in his 90s, and he said he agrees that it's wonderful that cartographers like himself can collaborate to this day with cartographers like me. And my gosh, that is so great. That is so wonderful. So he and I are collaborating with each other across generations. And it reminded me that the things that we work on, the things that we do, will live on after we're done with them, right? The work that we do persists, whether we know it or like it or not. They persist, and they have a life of their own. And you pour a little bit of yourself into everything that you make, right? It may not feel like it at the time with deadlines and stress, but you're pouring yourself into this work, and it lives on. And ideally, you can pour yourself into something that inspires somebody else, perhaps decades later, or perhaps right now, who will pick that up and turn it into something else for themselves and kind of carry that torch, that spark of creativity and passion for what they're doing. Now, we started by thinking of someone who has invested in us, and we said their names in our minds to ourselves. But at this point, I'd like you to think about looking forward in that perspective. So I'm going to ask you to think about the name of a person that you can invest into right now. So Who do you know that you can show grace, that you can dedicate time, that you can mentor? Someone who's new in their career or new in this pursuit, and someone who could use your help. So I'm going to give you a couple seconds to think of that name. And again, I hope you had a hard time thinking of just one name, because there's so many people that you can invest into and pour your experience and knowledge and wisdom into. So this is just a generic stock photograph of a forest, but it looks a lot like the forest that I was walking in for my second official GIS job. I was working for the Wampanoag tribe, a Native American tribe in the United States, living on a small island perched off of the east coast of the United States in the Atlantic Ocean. And it was my job to go out and capture the GPS coordinates of their abandoned ancient village. So it had been abandoned about 200 years ago, and it was their settlement, and they had built some homes there, and they wanted an archaeological representation of that. And the first step was to capture its coordinates geographically. And so once again, I strapped on a big GPS backpack onto myself, and I marched out into the wild. And here I was at the location that I was told to find the abandoned village, and I was looking for an actual abandoned village. And to my surprise, I saw essentially nothing except for eventually these very vague square patterns of rubble, stones, boulders, that at one time had been the foundations of small homes that people lived in. And I was really amazed at how quickly everything had been wiped away and nature had taken over. And there was nothing left except for these boulders, I thought. And I took a step back and I noticed a daffodil. One daffodil growing there, and next to that daffodil, though, was another daffodil. And they were neatly arranged in very geometric patterns. And the patterns surrounded the rubble of these ruined, abandoned homes. And they stretched out to what was essentially a ghost street and lined a non-existent road. Daffodils. So these little organic creatures have been blooming and falling back and blooming and falling back for hundreds of years in this location because they were planted by the builders of these homes and the people who lived in these homes. People who used stones for their foundation, but they also imbibed the place where they live with a little bit of charm and a little bit of beauty because they knew the importance of making something valuable and beautiful. And I was struck at the idea that the only thing that really remained was the beauty that they had invested in their work. The stones were gone, the houses were long gone, they were just heaps of stone. But these flowers were there representing the investment in beauty that the people who made these things put into their environment. And that's all I have to say about that. Thanks for listening.